So hello, everyone. My name is Dadno. I'm a solutions architect here at Arize. Um, so the first thing I want to talk about you with is really how does ML observability fit into the stack? Um, and so, um, the ML stack might include things like, your data source. You might have a feature store like Tecton, for instance. You may have a model store, something open source like MLflow, and obviously something that's doing some sort of kind of model serving. And really, that's where Arize or ML observability really fits in is when your models are actually serving in production. So as an example, I'm going to share my screen really quickly. And so let me know if you can see my screen, but really what I want to chat about today is what is ML observability? If I had to put it very simply, it's two things. The first thing ML observability is one, let me understand when something has gone wrong with my models in production. And really, the second is let me share my screen here. The second is really once you know something has gone wrong, you really want to understand why did it happen, where did it happen, and how can I kind of prevent this in the future. So that's what we think about when we think about observability. So maybe you're in the fraud space and you have a fraud model that's kind of helping you understand, hey, are these transactions fraudulent or not fraudulent? So what are some of the issues you might be seeing in production? Well, it might actually look something like this. Um, these problems can range from performance issues to data drift, all the way from to data quality issues and beyond. But the idea here is, there's a multitude of things that can happen in production, and you really want to understand when they happen and how can I pinpoint when these things happen? What's the difference between these kind of two things? And so we're going to take a quick look. I'm going to do a very fast kind of demo to show you and help you understand what are the things I can discover using ML observability. And it might all start off with something like this. It's an alert that says, hey, maybe we have an issue with our model. Maybe there's something that's kind of gone wrong. And it will take us kind of into the model, and we can understand things like, hey, is the performance of my model kind of up to par? Are there any hotspots in my feature that it may be not performing kind of super well? How is this data performing compared to maybe what I trained my model on? Is there a big difference between the two? Can we surface up what those issues are? And so that's for things like performance. One thing I recommend for folks when they're looking at performance is a lot of times us data scientists and machine learning engineers like to look at the statistically based kind of metrics. You can think false negative rate, AR, PR, AUC, things like that. But it's always important to tie this to the business, meaning, maybe I want a metric that actually measures, what is the total fraud caught in dollars by this model? Maybe I want to understand that and see, hey, are there any areas that maybe I'm missing fraud? When we think about data drifting or how things are moving, maybe at time of training, I knew the distributions of my model, but maybe those distributions have shifted since I've last deployed the model, and maybe I don't have production, kind of think those ground truths. Maybe I don't actually know if it's fraud or not fraud. How can I tell if my model is healthy or not healthy? Well, we can use things like drift. Very conceptually, to understand drift is if I'm looking at two distributions, you can think the blue one here is production, the purple one here is, my baseline, or maybe during training time. When this metric is very low, when this value is very low, they're more similar. And obviously, when this metric is high, they're obviously much more different. So you can think of drift as a kind of risk metric to the model. And of course, we can look at all the input features, how those things are changing. And so those are kind of the things that I want you to kind of wrap your head around as far as like what ML observability really helps with. It helps you understand, when things go wrong and why things go wrong, and what can you do to make those things better. The next thing I want to cover is maybe some new techniques in the field that are kind of happening. So foundational to a lot of the newer models, a lot of kind of the cutting edge of the future are embeddings. So if you're not familiar with embeddings, you can think of them as mathematical representations of data. Usually it's unstructured data. You can think computer vision models or language models. I'm sure we've all heard of large language models as well. Inputs and outputs of those can all be represented as embeddings. You can think of these as like a set of numbers that represent that unstructured medium. And one cool value of these embeddings embeddings that semantically mean the same or kind of like each other are similar to each other in the embedding space. And obviously, if they're not, they're going to be further away. So what are some of the things we can do with these embeddings? Well, we can actually take these embeddings and measure them and figure out, hey, is this thing drifting relative to this thing? Is the real world around my model changing? And so when we look at how this applies into the fraud world, we can do things like, I can actually take my tabular fraud data, right? If I know my transaction size, the user, what they spent their money on, how much, things like that. I can actually encode this data into an embedding. And you can do things like understand, we can understand univariately how things are changing, but maybe we want to understand in a multivariate sense how things are changing relative to each other or many things. So what we can look at here is, in this visualization, we can see, hey, when I'm comparing my data that I used for training versus my data that we used for, that we're getting in production, we can measure, hey, how different or similar are they? I said, embeddings are very highly dimensional math representations. You can actually project those math representations into a more intuitive space for a human, meaning, instead of asking you to project into 1,000 dimensions, what we're going to do is project these transactions into a three-dimensional dimension. So here, what we can see is, each of these points represents a transaction. And what you can do here is get a sense, because if you've ever dealt with fraud attacks, you understand that there's certain signatures to fraud attacks, meaning, fraud attacks don't happen the same way every time. Actually, as one fraud attack becomes known, right, you can think lenders and people who catch fraud kind of catch on to it. So fraud is constantly kind of a moving target. But what we can actually look at here is we can project each transaction into the 3D space. We can see, hey, what does my kind of baseline data look like? And does it overlap really well with my production data? We can actually slice and color tabular data on this kind of embedding space. So it's like, hey, if I wanted to see, hey, based off loan amount, do I see any patterns in this embedding shape? Is there anything that's happening? Let's say we actually know, which transactions are fraud. We can say, hey, my model guessed correctly that this was not fraud or wasn't fraud, or if we want to color by our confusion matrix, right, for instance, and we want to optimize for, our false negative rate, for instance, if we look down here, I can remove everything but those false negatives, meaning where is my model missing fraud? Is there something that these points kind of have in common? Is there something that they share from a fraud attack kind of perspective? Maybe it's a certain transaction size with a certain location, with a certain kind of user, things like that. But I really wanted to show the audience really kind of where the precipice of where kind of fraud catchers are kind of thinking. Really getting into this embedding space would be super important for them. And so that's what I have to show the audience today. Really excited to show, hey, what are the insights we can use with the embeddings that we have for tabular data. Happy to take on other questions as well. So thank you so much for attending this lightning talk with me. My name is Dat No. I'm a solutions architect here at Arize. Thank you so much.